I guess that started. Hi everyone, today is 31st March 2022 and we are Kubernetes batch working group. We have two items on the agenda today. First one is from Wang and then Chuck, please take it away.
All right, let me.
We need co-host.
Yes.
Okay. Yeah, I will share.
All right, it works.
I think you should have it now.
Yeah, it works. All right. Hi everyone. I'm Wei, and today I'm going to co-present the pod group API proposal to the working group. So basically, it's not a brand new proposal. So if you are familiar with the upstream, so basically pod group is a proposal we have presented like 2 years ago, but by that time, scheduling framework wasn't ready, and that proposal was based on a sub-project called scheduling batch, and the scheduling batch was incubated to another CNCF project called Volcano. So this is a more 2022 version of Power Group proposal. Okay, and the motivation is pretty straightforward. It's because that Kubernetes lacks an API to have a guarantee to ensure that we can achieve a semantics to run a group of pods altogether or run none. So due to that, without this guarantee, so for sure, sometimes your group of pods can be scheduled, but in sometimes the chances are pods may get partially scheduled, or even worse, the different groups of pods can run into deadlock among the different groups, so that they fall into pending state for each group. So this is basically the motivation. And we're proposing that we to define some top level API, Power Group API in the Kubernetes section Kubernetes. The goal is that we want to enforce this kind of Power Group API as a scheduling primitive, so that it's acting as a building block along with other scheduling directive primitives like pod affinity, pod topology spread. So because we have seen a lot of use cases pretty dependent on the pod group semantics, and also some complex scenarios like some TensorFlows actually semantically are using the semantics pod group as well as other existing semantics like pod affinity. So one case is that a TensorFlow wants to schedule, because lacking of this pod group API, they schedule the PS parameter servers pod first, and then schedule the other trainer or worker paths with the pod affinity with the PS pod. But you can see that it's problematic because in theory, they want the PS and the worker running all together. So in theory, if we can provide the pod group, fundamental pod group API, they can just use pod group API as a building block and just stack whatever other scheduling primitives just to fit their workflow. So that is why we want to propose it in the upstream Kubernetes instead of in the like as a CRD in some other repo. And another motivation is that there's a lot of definition of pod groups, like I will mention later, so that we don't want to diverge the community a lot, so that in the user's perspective, one single And unified API in the upstream in the Kubernetes will be very beneficial to the whole ecosystem. So basically, we want to ensure this is as a very fundamental scheduling primitive. So, and in terms of implementation, we want to we can support different kinds of implementation. So the upstream can have its own implementation, and also the other like Volcano and the Unicorn can use the same API but have different implementation. So we just ensure that we have the efficient scheduling, and in terms of preemption, we just be aware of the pod group. So the preemption strategy should be take pod group as a whole unit to consider its preemption strategies. And the last one is we should have a clear life cycle of how to manage the pod group. So this is basically the goals. Any questions so far? Any comments so far? Okay. If not, I will take a very quick look at the existing definition of pod groups. So basically, the scheduling plugins is the first one is a REPL that we exercise the scheduling framework to host a bunch of plugins contributed by different companies. And there is one called co-scheduling. So we already have a pod group definition here, and the Volcano is, as I mentioned, is the predecessor is called Kubernetes, and now it's a CSF standalone project. And also you had a pod group, and Unicorn is another kind of scheduler in Apache Foundation. So let's look at the definition for each. 1 second. All right, this is the scheduling plugins repo. You can see that pod group we have. So basically, it's just one level structure. For the pod group, we have the minimum member, so that only one the minimum member is rich. It's like a quorum. It's made it. We can schedule this bunch of pods altogether. And minimum resources is a field that it's like a pre-check. It's like a fast field test. That means you can define the minimum resources, and if this minimum resource is not satisfied, we fail the scheduling of the whole pod. So it's more like a faster check to fail fast. But in theory, you pass the min resources check doesn't mean your whole bunch of pods can be scheduled together. The last one is that we define the scheduling timeout to set a threshold to abort the scheduler attempt for the whole pod group. So this is the timeout settings. But you can see that some settings coexist in different scheduling vendors, but some are not. So this one is the.
Sorry, is mean resources for the entire cluster?
Yes.
Even if like they don't match like node affinities or things like that?
Yes, it's just a very primary resource check. Just a resource, yes.
But how does that work with auto-scaled environments where you don't know how much resources you could get in the future? But this is an existing provisioned infrastructure, right?
Yeah, it doesn't. So you can see that later I will propose that we don't introduce this field because it's not a mandatory field, and it doesn't, well, passing this check doesn't mean your whole bunch of pods can be scheduled. So yeah, but let's just put it on hold because some other vendors also use this field, but in my opinion, yeah, it doesn't matter too much to have this field or not. So if we look at the definition of volcano, so a lot of fields are almost the same, like minimum members, like the minimum resources, basically the same. So additionally, they have the priority class name. So in my opinion, it's in most cases, it's guaranteed that the paths associated with the pod group should have the same priority. So that means you can just derive the priority value from the pod group instead of define another field. So this field I don't want to propose in the new API. And the other one is Q. So I think Q is a good field to have because right now, although the internal scheduling framework doesn't support multiple queue, but we can have this field. So in one side that we can enable different scheduler vendors to support it well internally. And the other hand, in the future, if we are able to, scheduling framework are able to support the multiple queue, we can just natively support that for better scheduling efficiency. So this field, I think we can add. The other one is a bit interesting is that in Volcano is the minimum task member. So this field is one thing I also want to introduce, but in another way. So basically, the motivation of this field is that for now, if you look at the schedule plugins definition, is that it's just a one level. This pod group should have at least the minimum member, right? But in the real world case is that usually one pod group is mapped to one kind of job, but the kind of job can have different roles. So in Volcano, the role is mapped by the key, and then that kind of role can have a specific minimum member settings. For example, for Spark job, you have two kinds of roles. One is the driver, one is the executor. Usually they have the different requirement on the minimum members. So that in the Volcano, you can define like driver 1, executor 3, like that. But in my opinion, is that the string is a little weak to link to the particular role. So in my later proposal, I will make it more standardized and have some other field to for you.
Can I make a suggestion? It might be better to present what you're proposing, the problem, what you're proposing, rather than starting from comparing with others, because it's hard for us to understand what you're comparing with. I think if you present what you want to propose to have in the API and describe that, might be an easier to grasp flow.
Sure. Yeah, basically I have finished the comparison. So this is the definition for Volcano, and this is for Unicorn. Unicorn is not a style, but the core field here is also minimum member and the minimum resources. But it has some other fields. So it's like they are mixing some pod attributes into the task group, which I don't think is appropriate. This is the definition for. Okay, let's go back to the definition I want to propose. So the one I want to propose is just considering all the current scheduler vendors that define the pod group API. So the pod group can have a spec and a status. So for status, I don't think today we have enough time to discuss. We can leave it to next time or just discuss offline. So I just want to come to a consensus on the spec definition. So as I mentioned, so queue name and minimal resources, I just put them on hold. On one hand, minimal resources is that it's just a faster check. So I we can discuss later with other scheduler vendors how they design this field. And QNAME, very likely, I think we can have it, although it just can have a just default empty strings, and that means nothing for the internal scheduling framework implementation. Okay, the next field is subset. So each subset we can also name it like sub group or subgroup. It's represent a group of paths that represent a particular role. Here, definitions here. So the workflow is like that. A bunch of paths can be associated with the path group with the field in the path spec. So for now, let's say we can make it native. So path spec has a field called path group, and path group can link to the path group object. And then among the paths, because this path belongs to different roles, right? And this path should have a way to tell the scheduler that which kind of path that belongs to this role and which kind of path belongs to another role. So that's why we introduced the label selector, so that to distinguish the different kinds of paths within the same path group. So in terms of the Spark, we can define that one role is driver, and the label selector, you can have a unique set of labels to identify this kind of driver path, the same for the executor path. So this is the subset, so that we have a bunch of subsets. And the schedulability is that we need to ensure all the subsets, all the paths in the subset to be co-scheduled, and then we schedule the whole, the entire path group. Otherwise, we don't schedule any of them. And also schedule timeout is a settings that it's like a hard limit threshold to abort the whole attempt to schedule a path group. So this is the basic core of the new path group spec you want to define. Yeah, any questions?
I have a couple of questions, but I want to give the community.
Sorry, I have a question. It's more like if you can explain again what this subpod group is.
What this pod group is?
Sub.
Oh, subpod.
Yeah, the one
sure.
below. Yeah.
Yeah, this is in comparison with the current scheduler plugin definition, which is just one pod group is supposed to be one role, right? But in a real case, is that usually one pod group mapping to a job, the job has different roles. If you think about a real case, machine learning job is that a Spark job may have one drivers and a couple of executors. So this kind of definition is to simplify, that doesn't represent a real case of the machine learning jobs. That's why we want to introduce the leveled fields called subset or subgroup. And in each subset or subgroup, you can define what kind of role it is. And it has its specific minimum member requirement. And also the label selector is for scheduler to locate the particular role of the path. So this is the requirement.
And is the min member always mandatory? Or if I wouldn't specify the min member, even in the subset, would that mean that the min member is the size of the job, or how would that be?
In theory, most of the machine learning job have these few sets, but it's also possible that you backfill this kind of running workers along you have the like one kind of flow already running there. It's also possible, I would say. So Alex, do you have seen any scenario that we have minimum member equals 0?
Might be easier to describe what this is needed for. So the label selector identifies the group of pods that belong to this subset.
Yes.
But because you don't know whether these pods is being created or not, like all the pods that are should be created has been created, the min number basically tells the whatever the scheduler or any controller that's working on this structure to wait for at least this number of pods to be created with this label selector. And that leads me to my question, because this is kind of like, if you think about it, it's backwards. It's basically you're creating the pods and then you're trying to group them together, define the grouping of these pods, and then schedule them together.
Yeah.
So, and to me, like I argued about this multiple times before, it would have been much better if we didn't even create the pods in the first place until the resources are available.
I totally agree. It's not.
So that's just the.
It's not in conflict with some external controller to control the admission of the pod group. Actually, they should work together to achieve a better efficiency.
Yeah, I agree. I'm just saying that this approach in general, I know it is compatible, but even on its own, it could be problematic.
Yes. That's why we right now use some heavy extension point like the QSOT to ensure this kind of a group of paths are sorting back to back without even living too much, so that it will cause some schedule inefficiency. If we can leverage some external controller like Q with K, that to admit a bunch of paths at the same time, so the life will be easier for the scheduler to schedule this kind of bunch of paths. Yes.
Actually, I have a question around the APIs as such. Like, for example, Abdullah and others, they have defined the queued workload API, right? I'm sure that you might have thought about using the same API. Like, did you think about it? And can we introduce, because I look at some of the definitions, I think there are more or less similar to the definitions that are proposed there, but obviously we need something else. Would it be okay to use or reuse the workload API that has been defined there, the queue workload API that has been defined there? Or do you think there are some problems with that?
Yeah, that's a good question. I thought of that as well. And also in the beginning is that I also suggest that Abdullah, that can we have a neutral name for the queued workload, and so that it doesn't necessarily mean it's a controller behavior. Instead, you can have both controller behavior and scheduling behavior. But it ends up with that the queued workload more represent that particular semantics that runs outside as is associated with like quota with admission. So how one API to fit two purposes that can be possible, but in practical, I don't think it's involves additional efforts to maintain this to fit two purposes, and so that the additional and the redundant fields have to be set in one API. And on the other hand is that I do want to propose this in Kubernetes/Kubernetes. And for queued workload, it seems it has to go with the CRD path first. So that is another consideration.
So to be clear, what you are saying is you would like to propose this API in KK
Yeah.
for Kubernetes
Yes.
directly
Yes.
as a top level API.
Yes. Yes.
I see.
Okay, I have a few questions related specifically to pod groups. The current design that you're proposing seems to be targeting only the scheduler part.
Yes.
Because
exactly.
This is only to tell scheduler that it should be, that's how you should be treating the pods coming from here. And if so, it's very decoupled from the pod template or in general in pod. So for example, if I'm creating a job or any kind of the workloads resources, I'm required to create the pod group separately.
Yes.
Have you considered embedding the information about the pod group inside of the pod template?
I do.
As
I
an
do.
optional field?
Yes, I do. So basically, the downside of embedding the pod group spec into the pod spec, just like topology spread constraints as well as pod affinity constraints, is that the pod group fields actually compose, in this case, different roles of the path, right? Virtually. It's not that the pod group define this kind of images for different kind of roles. It's virtually that organize different kinds of role paths. If we define this through a pod template, so that like the driver path and the executor path don't have a way to be virtually organized as a unit, so that can be easily scheduled by the scheduler. So that's the main concern for why not define it as a embedded, not top level API to the pod stack. And I think another.
You have the label selector, which can distinguish these two groups of pods. Like, imagine your Spark job. So you create two, you will have two pod templates, one for the driver and one for the workers. And each one of them would have a different pod group label selector. Wouldn't that address the concern you just mentioned?
But there's some top level cannot be defined easily. Like if we have queue name, you have to duplicate, define that. And also the term out seconds is a top level, it's not a subset level. So that's also a problem.
Sorry, can you say that again?
So basically, yes, label select can help schedule locate the paths, but there's some top level in the job level, in the pod group level settings like queue name and schedule timeout seconds here. So yeah, definitely we can duplicate these settings to two different kind of pod templates. That sounds a bit redundant. And also, if the other scheduler vendors do need this minimal resources field, that doesn't sound a good fit to define the pod template.
Right, but like,
although,
I mean, the fields that you introduce here should also, like, we don't usually have fields that nothing in KK acts on, because they serve as, it's confusing. So I agree that we should have hooks to enable other frameworks. But I would expect, if you go through an API review, to get a ton of pushback on having a field that's just doesn't mean anything to core Kubernetes.
For core Kubernetes, is that we want to have a very basic building block, fundamental ability to express this kind of semantics. It's not, I won't call it additional good head feature. It's more for you to build more complex batch workloads, right? So for now, because of its limitation, a lot of workflow is built in a very weird way and not guaranteed way to achieve a whole batch workflow. So that is the basically I think the key thing to propose in Kubernetes. Kubernetes. Okay. Well, another thing I thought of why define a pod group instead of embedding all the spec is that we can have a controller to watch the pod associated with pod group and show out the status. The status can be pretty helpful in one hand to let the user know the overall status, and the other way is to can be associated with the CA to spin up new missions to make this kind of whole pod group schedulable. That is another benefit to have this.
So currently, as it stands, I'm leaning towards what Abdullah is saying, that it'll be very hard to get this accepted in the core. If that would be something that would be embedded inside of a pod, the existing pod spec, pod template, whatever, where you can easily bubble it up and reuse within the current controllers, and you have a little bit more control over how the pods are being created for your application, no matter whether that's a daemon set deployment or job or whatever else. If this is, and the way you are presenting it, this currently looks like a entirely separate thing, and I'm pretty convinced that the pushback will be that if this is a separate thing that just exists and only the scheduler would be the only one using it, that could be easily a CRD, and the scheduler extension being a plugin that you just have running on your in your environment. If we would push, or if you would want to have that one in the core, I think you would need to have a tighter coupling with the existing APIs to be able to get it accepted. As it stands currently, I'm pretty convinced that any API reviewer will reject this. That's my personal opinion.
Okay, fair. Yeah, that's very good point.
Maybe I would like to give some context. I think, as you said, like it would be ideal if we could embed these fields into existing APIs. So naturally, the API that fits it is probably the job, because it already groups a lot of pods, right? And you could set these configurations there, for example. But the reality is that the job cannot satisfy all the requirements that different types of batch workloads have. So we need something in between to be able to represent arbitrary workloads that ultimately need to be scheduled together, right? So that's why we cannot simply put it in job, and in pod it looks awkward because it's repetitive. So we need a solution somewhere, and I guess that this is an approximation.
I mean, what I'm asking is if we will be take a step back, is it something that we would only benefit for jobs and nothing else? With something similar or something along those lines would be used in I don't know, deployments or daemon sets or replica sets or any other of the other workloads?
I think it's universal. So I can give an example of non-batch workloads that internally we have a team, they want to run pod affinity, but due to limited resources, the pod limiter usually falls into a situation that the first couple of pods, okay, gets scheduled to the same node, but the latter one cannot come in, get pending there because the limited resources on the node. So in terms of their requirement, they want to use pod affinity, and they do want all the paths using the pod affinity to be co-scheduled to the node. But it doesn't mean that necessarily they are using a batch workflows. They are maybe using the standard deployment. So that's why I say this can be a universal requirement, and I think it's a fundamental scheduling constraint.
Right, like the example that we gave, I think it's imagine you have I don't know if you're familiar with Istio, for example. You have a proxy associated with each service pod, and for security reasons, you don't want that proxy to be a container inside the same pod. The proxy is trusted component, but the main worker is not, and so there are what usually people want to do is to split the proxy, but the proxy has to be running on the same node, and they would communicate via locally. So that's why the other case here is for other than jobs. Some actually batch workloads use deployments in a sense because they are kind of like, imagine the workers, for example, in Spark, you could deploy them as a deployment that the driver is communicating with to give them workloads, to give them like tasks, basically, to chew on. So I would agree that this is not limited to the job API in general. It could be something more like more abstract. I have another proposal here that I'll share with the community along the same lines in general, and the idea at the higher level is like right now we have the pod representing two things. It represents the application itself, what you want to run, and it also represents the provisioning requirements, right? Like what exact resources you want. Imagine if we have a resource called reservation that doesn't contain, like, it's a pod that doesn't start, basically. That the scheduler is aware of, cluster autoscaler is aware of, kubelet is aware of. And so you could create a reservation that the scheduler schedules. Kubelet also takes it into account when it does its admission logic. Cluster autoscaler takes it into account when it's doing its calculations to whether or not provisioning new resources. And this reservation resource, you create it before you create your application pod. Once this reservation is, and so basically after when you create the pod, imagine that the pod has an affinity to that reservation. And so the scheduler job here would be, if a pod has an affinity to a reservation, it would just basically schedule the pod on the same place where that reservation is. If it doesn't exist, then it's just going to continue to be pending. And so if you have that decoupling of resource provisioning from the application, you could do even more powerful stuff, I think. You could have a controller that creates a reservation set. A reservation gets, and the scheduler would be still working at not at the group level, but works at, at the instant, like reservation level, like one instant. Like assume that the reservation is a single pod, for example. But I mean, I don't want to confuse people with just like, wishy-washy hand-waving talk. I'll share something along the same lines as well. I think it's a really interesting, area in general. Like, how do we solve this? Like, all or nothing is a really big problem that we need to solve. I completely agree with Wei here, and this is a really good start. Like the pod group idea, resurfacing it, trying to discuss it. Maybe we can continue discussion on the document that you have way there. and see where we can go from there. Maybe we can fine tune it, make it more potentially acceptable to the API reviewers. Maybe we can get some of the API reviewers to take a first pass at it as well.
Yeah,
See
exactly.
what is that? Yeah, what things that they could spot.
Yeah, sure. Thank you. Yeah, the idea you proposed sounds pretty interesting, and looking forward to take a look at the proposal.
I want to say, I like to add something I learned from the users. I find about 80% of the users who choose to use Volcano or another custom schedulers just because they just want to use the gun scheduling. And it's already be a basic feature for the batch group, or especially in distributed training of the deep learning. I think if we can support it in the KK, and it would be a good opportunity to help to bring the users back to the native Kubernetes system. Yeah, I think no one really like to run two scheduler in the same cluster. Yeah, it also can lead to a lot of problems. So I think it's also the goal of our work group. Yeah.
Yeah, well, another thing is that with this API, if we can make it in Kubernetes/Kubernetes, it's also beneficial to other scheduler community, because they don't want to, the user doesn't need to diverge into a different kind of version. So if API definition is just what kind of implementation they choose. They can choose the default scheduler, they can choose the Volcano. So, but their workflows is consistent across different implementations. So that's another benefit, instead of locking to a particular version of the part group definition. Yeah. Okay, lastly, there's still one piece I want to discuss is the part group's life cycle. Also, it's partially discussed in message statements. So how is this part group's API object is associated with the part spec? So I also discussed with Alex offline. There's a couple of ways, but in terms of the best way we think is that the part spec has a field like called part group name or part group, and that part group is associated with a top level API object called the part group. That means the users should define the part spec and specify the part group field. And then the part group also needs to be created by the users and to define the scheduling constraints to schedule this kind of paths altogether. And there's some other alternatives. I have a detailed analyzation, but I don't think we have a lot of time to discuss, right?
Yeah, I think we are on top of the calendar invite. So I think we have another item as well, and we're not probably going to get to that. So I apologize to Abdullah and Aldo. I'll probably move that meeting to next week, and we'll discuss that. And we thank you so much for coming and presenting. This was an interesting discussion, and we can continue the conversation on Slack or continue commenting on the document that you have here. If you want to share it or put a link in the agenda, itself, that would be great.
Yeah, I will polish the things a little bit and share with you.
Perfect. Thank you so much. I'll probably close the meeting now. Thank you everyone for attending.
Yeah, thank you.
Bye.